Welcome to the presentation of Type, an educational live programming environment to compose graphics with PyTamaro. Let's see what PyTamaro is first. PyTamaro is a graphic library that is targeting beginner students who are learning to program. The library provides very simple primitive shapes that you can use to create graphics. For example, you have a rectangle shape, a triangle shape, ellipse shape, circular sector shape, and text shape. And this is all you get. And what you do with this shape is that you compose them. So you can put one on top of the other. So for example, here to create a Swiss flag, we put a white cross on top of a red background. Or to create the Italian flag, you put the stripes beside each other. So you have the white stripe and the red stripe, and you put them beside each other, and then you do the same for the current stripe. Or you can put them one above the other to create, for example, here the German flag. We have a web platform called PyTamaro Web, where us, the research group, and teachers that are using this library in schools upload activities where you have some text intertwined with some code cells that you have to write some code that is using the PyTamaro library to create some graphics. Now, when you use PyTamaro in an educational environment, you usually have a problem that is to create a graphic, and the solution to that problem is writing the code that produces that graphic. And for beginners, this is a very hard task to do because they are not used, for example, to the strict formalism of a programming language. And so they struggle a lot with the syntax, for example, at the beginning. And to ease this problem, we have an unplugged visual programming language called TamaroCards, which allows students to bridge between the problem of creating a graphic and the code, and it works both ways. So let's take a look at this visual programming language. The language is targeting a very small subset of the Python programming language, and it's a pure subset of the language. It only has very few constructs, so you have literals, for example, the number literal, you have name usage, and you have function call. And each one of these is represented using a card. We also have support for more advanced language constructs like function. So you can create your own function, and then you can use that function using these cards, or you can use the same as with names. So you can create your name, your constant, your variable, and you can use it. Using these cards, you can have a mechanical process to go from the cards that you compose. So you put pieces of cards side by side to create your graphic. And then by looking at this composition of cards, you can create the Python code that will correspond to this composition mechanically. So for example, here you will go from the rightmost node, so the above card there, and then you can write the name of the function. This is a function card, so you write the name of the function, and then you have two parameters for this function. So you open a parenthesis and you follow the first parameter, and then you go here and you have the triangle. So it's another function. So you write the name again, open the parenthesis, you follow the parameters. So you have 100 here, 100 here, then you put the commas in between them, 60, comma, and then you have red. In this case, this is a name card, so it's using the name red. This is the last argument, so we close the parenthesis, and we can go back up here, put a comma, and we repeat the same process for rectangle. So rectangle, open, 100, comma, 100, comma, white, close, go back, close. And so in this way, you can get mechanically the piece of Python code that you will need to write to create the graphic that you compose using this visual programming language. When teachers use TamaroCards, they use them in an unplugged environment. So students have to draw the cards on paper, or they use paper cutouts and then connect them together by drawing lines. And they can also evaluate the cards by drawing the graphics that are produced by them, or by using paper cutouts for the graphics that are produced as well. A complaint that students often have about this approach is that it's not programming, it's not learning to program, because it's not something on the computer. And so to ease this problem, we have introduced the TamaroCards IDE, which is the equivalent virtual version of the TamaroCards that you would use in an unplugged environment. This is styled a live programming environment for TamaroCards. On the left side, you have this palette, which contains all the TamaroCards that you can use to create programs. So let's take this guy, for example, rectangle, and let's drag it onto the canvas. When you drag a card onto the canvas, you can select it, and you can see the documentation for that specific card. So let's see here, for example, that rectangle takes 3 parameters: width, height, and color. And so we can use the cards here to put the numbers as arguments. So let's say the width. You can also create specific values by typing them down below. The height, and let's do the color red here. So red. But there is an error. So you see that it's telling me that it's expecting a value of type color, but it got a string instead. See color here and str for string. And in fact, if we look at the documentation and the example, you see that the green is not between quotes, which means it's a name. So we have to use a proper name. We don't have to use a string. So we can, let's take black here, for example. And you see that you get the name card black with a little paintbrush with the black tip to show you that it's the black color. Then we can connect it, and you see that now the rectangle card has the graphic that it's producing on the right side of it. And now, since this is a live programming environment, we can change the values, and the graphics are going to be updated automatically. So we say change the width, and it's going to look at wider. You can change the height, make it taller. Let's go back to the square, and we can also change the color here. So you can make it red, and it's going to turn red. Now, if we use a color that does not exist, for example, orange, there's no orange color in PyTamaro library, you get a name error, which is the same error you will get in Python, which is the constant orange is not defined. So let's put it back here. So red. And now we can try to build a small house. So we can, this can be our wall, and we can add a roof using a triangle. So we can check here the documentation, side 1, side 2, angle color. You can also see it here, but it's missing the arguments for the parameters, so it cannot produce a graphic yet, but now we're going to add them. You can drag it, and we can also copy paste using Ctrl+C, Ctrl+V, or Command+C, Command+V. Two sides, and also the color we need. So let's connect the color and the angle here. Now this is another error that you can get. This is a value error, and in this case you have the angle that is bigger than 180, which is not possible for a triangle to have an inner angle bigger than 180. So we can change the value here, and we want to make it equilateral triangle, so we're going to make it 60. We can make the wall white. Okay, so we get the white wall and the red roof, and now we put them one above the other. So we put this on top of that, and you get the composition. You see, but the roof is too small, so now we need to update the value to make it the same as the side of the house, of the wall, and now you got the proper house. You can change the values here. For example, we can make the roof green, and it's going to be updated everywhere. What's interesting is that if there is a mistake in a particular sub-expression of this tree, the error is going to be shown, but the part that doesn't have error is still evaluated. So let's say that we make a mistake here, and we use the color A, which does not exist. You see that the final composition is not shown because there is an error in this piece of code. And we can see that this is highlighted in yellow, and we can follow the yellow highlight to see where the error actually is. So you see that there is 2 arguments coming in this function invocation, and we see that this guy is highlighted and this one is not. In fact, if you follow this guy, you see that it's still producing the proper graphic. It's still producing the white square. So we follow the other guy to find where the error is. See that there's yellow highlight still here. And then we check this one does not have a highlight, and this one has an highlight. And so we follow down here, and we see that there is an error here, which is the name error constant A is not defined. You can also find where the error is more quickly by going to this button here, and then you see that name error constant A is not defined. Then you can also click on this icon to get a zoom onto the card as the error. So let's put it back here to right. You can make the house taller, do that, and it's going to be updated automatically. Now we can take this composition and we can save it by using the export button down here below. Name it house. We can save it, and we can delete it, and we can bring it back here and see. Now another thing that we can do is using abstraction, but it requires a more complex example. So I have here a composition for a Swiss flag, and you see that there's the cross here, and the cross is made of 2 arms, and the expression that we use to produce these arms is the same. So you have this expression here and this expression here, which are identical, and so this is called duplication, and we can't remove code duplication. And how do we do that? Well, for example, we can introduce a name. Let's say that this is the arm, and then we use the name arm twice, once here and once here. So we overlay the arm and the rotated arm to get across, and so we remove the code duplication. So let's do that. So we identify the part of the code that we want to use as the value for our variable or constant. Here it will be this guy and its arguments. So we can click on the card that we want to put into the constant, and we can right click and extract sub-expression as tree constant. So we create a name for our constant. Let's call it R. Confirm. And you see now that I got this blue box here, which is a name definition for our constant rectangle, the values we had before. And now it got replaced here with the card with the name R in it. We can take this guy here now. We can remove the connection. We can remove the whole expression as well. And instead we can take this card, which is we're going to type R, and we are going to connect it to the overlay. And so now you see that we have name definition, and we use our custom defined name R twice to create our Swiss flag again.